So our very last thing we're going to work with polynomials is making sure that we do what's called factor completely. So we've learned all of the different ways to factor. What we haven't had to do is make sure that we have factored it completely. Factoring it completely means are you sure there's nothing else you can do with it? We have to know how to factor, so we can't factor anymore, because factoring helps us be set up for solving equations. And so if you can't factor, then we're going to have trouble with solving then later on. Okay, so let me get this view put just a little bit smaller, I guess, here so we can see it all. Okay, so when we are factoring completely, here's the first thing we're going to look for. Is there a GCF among the terms? Every time you're now going to factor, you're going to first ask yourself, is there a GCF? Okay, if yes, factor it out. I want you to put a comma here. I want you to make that period into a comma. If yes, factor it out, then move on. In other words, you're not done just because you factored out a GCF necessarily. You're going to move on and ask yourself some other questions. If you have to say, no, it can't be GCF, you're still not done. In other words, you don't get to say, well, it can't be GCF, so they can't factor it. No. If no, then move on. You just don't have to worry about a GCF. The next question you will ask yourself. So this is the first thing. You always check that out first. And then next, the second thing you're going to do is look at the resulting, what you have left, and say, how many terms are there in the polynomial? So let's say you're able to GCF. So you have this GCF monomial up front, and then in parentheses you have another polynomial. You're going to look at that polynomial and you're going to say, how many terms are in this polynomial? If there's 2, this is what we're going to look for. Is the binomial a difference of squares? Remember our special binomial? If it's the difference of 2 squares, that means it's factorable. If it's not, then we're done. We don't have any other means of factoring binomials. Once we've GCF'd them already, if it's not the difference of 2 squares, then we can't do anything with it. But if it's 3 terms, that means we have a trinomial. Now we're going to ask ourselves, can this trinomial be factored into those 2 binomial factors? And what do we use to make that happen? What method do we use when we're factoring a trinomial? What do we start with? I make it as an X, but we call it the what? Diamond method. So we're going to see if we can factor it using the diamond method. If we can't, then we're done. Well, if we have 4 terms in that polynomial, now we're going to say, oh, that means I got to try the factoring by grouping method where I can make 2 groups of 2. And I'm going to see if I can factor it by grouping. If I can, I move on and do it. If I can't, I'm done. Now, I'm always going to tell you, like I do in that homework right there, how many are not factorable at all. But what I'm not going to tell you is, if you can GCF it, can you still factor the polynomial that is not the monomial GCF? Can you factor that? But you can be guaranteed that while we're practicing, you're pretty much always going to be able to keep factoring. You can't give up too early. So what's the first thing we're going to look for when factoring a polynomial? The GCF. We're going to see, does it have a GCF? We always need, that needs to be our first thought process. Can I GCF this polynomial? After we do that, if the polynomial that we have, that's not a monomial GCF, if that has 2 terms, what special product are we going to look for? What's that called? Something to do with perfect squares. But it also has to have what? It has to have a perfect square beginning, a perfect square end, and what operation? Difference. We have to have subtraction. So we're going to look for the difference of 2 squares. So first of all, does our binomial have subtraction? It does. Is the first term a perfect square? Is the other term a perfect square? Well, what if it has 3 terms, not 2 terms? What if it's a trinomial? What are we going to look for? Can we what? Yeah, we're gonna identify A, B, and C, and what are we gonna do with that A, B, and that C?
Add the A and the C and then add
So basically what we want to check for is if it can be factored into two binomials. And our method for that, the diamond method. So what we're looking for is, can I factor it into two binomials? And I know I can use the diamond method to try that. If A is not equal to 1, I know not only have to use the diamond method, but what else? If A is not equal to 1. I can't stop with just the diamond method. What else do I have to do?
you're gonna FOIL it.
You're going to do factoring by grouping. Yeah, we got to do that. Okay, so we'll practice this. And then number 4, if the polynomial has 4 terms, so in other words, it's not a binomial, it's not a trinomial, it's a 4-term polynomial, what are you going to look to see if we can do? Factoring by grouping, yep. Check for factoring by grouping. Make your groups and try to factor by grouping. Okay, so we have 3 of them that we're going to practice here. And we're going to run through this sequence. We're going to first check for GCF, and then we're going to ask ourselves, is it a 2-term, a 3-term, or a 4-term polynomial that I have left? And can I factor it? So we're going to go to the work page. So let's go to the next page that I gave you. And I've written down problem number 5, because that white space down there is not near enough work, or enough space to do it. Okay, what question are we going to ask ourselves about this trinomial?
Or is it a GCF?
Can it be GCF? Okay, take a look at it, decide. Can this one have does this one have a GCF?
No.
8? Can we factor an 8 out of all 3 terms?
Nope.
No.
Can do a 3.
Can we take a 3 out of all 3 terms? Can out of a couple of them, but we can't have a 20, can we? This is not a GCF. We aren't going to say it's not factorable, we're going to say this. No GCF. But we don't get to stop there. Now we move on and say to ourselves, is it a 2-term, a 3-term, or a 4-term polynomial? 3-term. Okay, if it's a 3-term, we're going to look to see if it can be factored into 2 binomial factors, right? So we're going to look for the, so let's write in our notes that we have a trinomial with A equals what? What's our A equal? 3. B equals -20, and C equals 12. Okay, so A is not equal to 1, so we have to use the diamond method and the factoring by grouping, don't we? Okay, so let's go to work. We have to take our A times our C, so we have to take 3 times 12. What is that? 36, okay. And they have to add up to what? -20. Okay, let's make this happen. What multiplies to be a positive 36, but yet adds up to a -20? So both of them have to be what? Negative. Noah, what do you think they are?
-2 and -18.
Okay, -2, -18. 2 times 18 is 36, and a negative times a negative is a positive 36. And yet they add up to a -20. Now, what do these become though? They become x's, don't they? Those are actually x's, aren't they? So now we're going to rename our trinomial as a 4-term polynomial, replacing the subtract 20x. We forgot to change it to add the opposite, didn't we? Subtract 20x, or our -20x is going to get replaced with the -2x and the -18x, and the first term and the last term stay the same. Okay, go ahead and factor that by grouping, because you know how. Factor that by grouping. Make your groups we need matching factors, right? So that's 7 GCF. Positive 6 doesn't work, so we change it to a negative 6, right? Okay, so now we are ready to write the factored name for this trinomial. It is what? No more plus sign, x minus 6. Okay. So, you're probably like, well, that isn't any different than what we've been doing. And that one wasn't. Why? There's no GCF. Okay, there's no GCF. So that's why it didn't feel any different. We had a trinomial with an a not equal to 1. We had to use the diamond method first, and then we had to do the factoring by grouping. Okay, now what we will also do, I think reserving those for tomorrow, but when we factor completely, even when we're done factoring and we have factors, we have to ask, can those factors be factored? So in other words, can we factor 3x minus 2, or can we factor x minus 6? But today, we don't cross that bridge today, we do that tomorrow. Anybody have any questions on that one? Okay, what do you think about number 6? 2x squared minus 50. Okay, we have to ask ourselves this question. We have to ask ourselves, is there a GCF?
Yes.
Okay, so before today, here's what we would have done. We would have looked at this and said, this is a what? What kind of a polynomial do we have?
Binomial.
It's a binomial. It has subtraction. We would say, is 2x squared a perfect square? No. So we would stop and say it's not factorable, wouldn't we? But today we're saying, no, we're smarter than that now. Now we're going to check first of all to see if there's a GCF, and then see if we can go from there. So this one has a GCF, so we are going to take a GCF out, which is 2, am I right?
Yep.
Okay. So when we take this and GCF it, look at what we end up with. Now we have to ask ourselves, that resulting polynomial, we got that x squared minus 25, now we have to run it through those tests. It's a 2-term polynomial, so we have to ask ourselves what? Is it the difference of perfect squares? It's a subtraction. Is x squared a perfect square?
Yes.
Is 25 a perfect square?
Yes.
Is that factorable then?
Yes.
Yes, it is. Okay, so here's what's going to happen though. This is what you'll accidentally do because we factored it out at the beginning and we're not going to use it for a little bit. You're going to forget about this too. So here's what I want you to do. I want you to put an arrow saying, you know what, I'm going to arrow that 2 down. I'm not going to forget about it. It's still part of my final answer. And now I'm going to do here's what I have to do. Here's my work I have to do to get my x squared minus 25 factored. And I actually, I'll just do this. X what?
X plus 5. Times x minus 5.
Okay. So all we're doing right there is factoring our difference of 2 squares, aren't we? Now, that 2 that had to come down, it says, you know what? I'm going to join you. I'm part of the final answer. So 2 times x plus 5 times x minus 5. There's the final answer. We can't forget about that too. Because if we just multiply it, remember our factor name should always multiply back to what we started with. So if we would multiply, we forgot about the 2, and we would multiply x plus 5 times x minus 5, it would not take us back to 2x squared minus 50. So that 2 has an important part in this. Okay? Any questions? Okay, we got one more to do, right? Let's go to the back side of this work page. Okay, go ahead and start this one. Okay. Start it. you're already factoring by grouping, you might as well stop. You forgot to run it through the first test. What's the first test?
It's factor or GCF.
Is there a GCF? Is there a GCF for this one?
Yes.
Sure is. What is it?
2x.
2x. So, save you too much erasing. We have to GCF this first. So, we're going to 18x to the fourth divided by that 2x is
9x to the third.
9x to the third plus 12x cubed divided by 2x, Abby? 6x squared plus 6x squared divided by 2x, Devontae?
3x.
3x. 4x divided by 2x, Aurora? 2, you got it. Okay, there we go. Now, how will you know if you've got the right GCF? Well, you're going to look at those 4 terms and see is there anything else that could have been divided out of all of them. Is there anything that goes into 9, 6, 3, and 2 other than 1?
Nope.
How about, do they all have X's?
Nope.
Nope, this one doesn't, so we have a good GCF. Okay, now, we can't forget about that 2x, so what are we going to do with it? We're going to arrow it down. We're going to say, you know what, I don't want to forget about you, so I'll do this. And now I'm going to pay attention to the resulting polynomial I have after that GCF. It's a 4-term polynomial, so now are we ready to try factoring by grouping? Yeah, now we can do the factoring by grouping. We're going to have the 9x cubed. We'll group it together with our 6x squared. And then we will group 3x plus 2 together. What's the GCF of the first group? Faith?
3x squared.
Yeah, I agree. 3x squared. 9x cubed divided by 3x squared. Michaela?
3x.
3x, that's right. 6x squared divided by 3x squared. Noah?
2.
2. Bring down our plus sign. What's the GCF of the second group?
1.
1. Do we have to write it? Yeah, we do. We do. Even though a GCF of 1 doesn't really get you anywhere in this case because it's one of the GCFs of only one of the groups, we have to write it. And of course that means the other, factor is going to still be that 3x plus 2. Okay, what is the factored name for this one now, Claren?
2x parentheses 3x the second plus 1.
No, I don't want to talk about that. I'm still finishing my factoring by grouping. I just want the factored name for the 4-term group, this one.
3x the second plus 1 times 3x plus 2.
Okay? And now, we're going to say, but 2x is going to come along, right? It's part of the name. So our final answer is 2x times 3x squared plus 1 times 3x plus 2. Does it matter which of these two comes first? The 3x plus 2 or the 3x squared plus 1? No. Typically, though, you will see the monomial up front. Okay, so if you have a monomial factor like we do, 2x, if you have a monomial factor, that's usually up front, and then the binomials, the results, can be in the order that you choose. Okay? Factoring completely. So you're always going to ask yourself, what first?
GCF.
Can I GCF this? Okay? So, this is the end of our note-taking together, and so you're going to be doing that book assignment where it says 3 are not factorable at all. So in other words, you're going to try to GCF it, and you can't GCF it. You're going to try to do one of the other things, and depending on how many terms there are, and nothing works, so then you say it's not factorable. But only 3 of them.